Hello students, I'm your host teacher Mohammad Ashraf Wani, and today I will be delivering a topic, types of chemical reactions. Well students, we have discussed in our previous lecture about what chemical reaction means, what chemical equations are, how balancing of chemical reactions is done, and the most important characteristics of chemical reactions. Today, I will be delivering on the topic types of chemical reactions. And the very first type of chemical reaction that we will be discussing is combination reactions. Dear students, this word "comb" simply means to bind together. And in these combination reactions, if we have to define them, this word combination reaction are those reactions in which two or more reactants combine together to form a single product. We can have n number of examples to explain this. For example, let's take a reaction in which we see carbon combining with oxygen to give carbon dioxide. Now in this reaction we see how carbon is combining with oxygen and the product which is formed here is carbon dioxide. Now carbon and oxygen, these are two reactants which are combining together and the resultant is a single product, carbon dioxide. Similarly, if we go with the formation of water, when water is formed, how hydrogen combines with oxygen to form water, H2O. And in this reaction, we see how hydrogen combines with this oxygen and results in the formation of single product, that's H2O water. Similarly, we can take one more example of the formation of ammonia. Nitrogen combining with hydrogen and resulting in the formation of ammonia, NH3. In all these examples, in all these reactions, we saw two reactants, they combine together to form a single product. They just form a single product. Such reactions in which two or maybe more than two reactants combine together to form a single product are called as combination reaction. Now after combination reactions, we'll be discussing one more type of chemical reaction, that is decomposition reaction. Well students, when we talk about word decomposition, it simply means breakdown. Yeah, this word decomposition means breakdown. In decomposition reactions, we have a single reactant, and this single reactant breaks down into two or more simpler products. Let me explain it with the help of an example. For example, if I take a reactant, calcium carbonate. Now this calcium carbonate, if it is heated, it breaks down into, this calcium carbonate, it breaks down into calcium oxide and carbon dioxide. In this reaction, we see how a single reactant calcium carbonate is breaking down into two simpler products, calcium oxide and carbon dioxide. So this reaction is a decomposition reaction. And if I go for the definition of the same, how to define them, decomposition reactions are those reactions in which a single reactant breaks down into two or more simpler products. But one thing you have to keep into notice, that this breakdown of a reactant into two or more simpler products always takes place with the expense, with the help of an energy. Yes, dear friends, this energy is required to break this single reactant into simpler products. And this energy which is used here can be in different forms. It can be in the form of heat, it can be in the form of electric current, it can be in the form of light. So energy is required, and is required in different forms to carry out this decomposition reaction. The example which I just quoted in front of you, decomposition of calcium carbonate. Now this decomposition takes place with the help of heat energy, and this is called thermal decomposition. And if we talk about electrolysis of water, in which we have this water through which current is passed, electric current is passed, it breaks into hydrogen and oxygen. Now this is again decomposition reaction, but this decomposition reaction takes place with the help of electric current. So we call this decomposition reaction as electrolysis. The word lysis means break down, and electro means with the help of current. So this decomposition reaction, decomposition of water into hydrogen and oxygen, takes place with the help of electric current. So this is electrolytic decomposition, or simply electrolysis. Now let's take one more example in which we can discuss about photolysis or photolytic decomposition. Let me take an example of compound AgCl. Now this AgCl is a photosensitive compound, which means simply it is sensitive towards light. Now this AgCl, if it is exposed to sunlight, means when sunlight falls on this AgCl, it's exposed to sunlight, it breaks down into Ag and Cl. So here, the energy which is required to carry out this decomposition reaction is in the form of light. So this type of decomposition is called photolysis. I will repeat. In decomposition reactions, I talked about thermal decomposition, I talked about electrolysis or electrolytic decomposition, and I talked about photolysis or photolytic decomposition, depending upon what type of energy is being used to carry out the decomposition of a given substance or a reactant. Well, one more important thing which I would like to add is this, that when we were discussing about combination reactions, we mostly saw these combination reactions, they involve release of energy in the form of heat. And all those reactions, like I discussed, carbon combining with oxygen resulting in the formation of carbon dioxide, and in this reaction heat energy is also produced. Hydrogen combining with oxygen to give water, heat is produced. Nitrogen combining with hydrogen giving ammonia, heat is produced. Even we have calcium oxide, if it combines with water giving calcium hydroxide, even then also heat is produced. So all these combination reactions, they are accompanied with liberation of heat, release of heat. Means these reactions, especially I'm talking about combination reactions, whenever combination reactions take place, they generally are accompanied by release of heat. And these reactions in which heat energy is given out are called as exothermic reactions. I repeat, those reactions in which heat energy is given out are called as exothermic reactions. Coming back to decomposition reactions, we saw there are many reactions which are taking place on the expense of heat energy. Well, you require heat energy in order to carry out those decomposition reactions. Well, I am talking about thermal decomposition. And in those reactions, like we discussed about decomposition of calcium carbonate, this calcium carbonate is heated to break it down into calcium oxide and release of carbon dioxide. Now this reaction in which heat is required to carry out the reaction, energy is required to carry out the reaction, are referred as endothermic reactions. The word endo means in, thermic heat. So heat is taken in to the reaction to carry out the reaction. So we have exothermic reactions in which heat is given out. We have endothermic reactions in which heat is taken in, absorbed. Well, after combination reaction, decomposition reaction, we have third type of reaction known as displacement reaction. Well, this word displacement needs to be understood first. Displacement simply means if we have a certain thing at a certain place and something else comes and displaces that original thing from its place, it's simply referred as displacement. Well, let me make you understand this concept with the help of an example, with the help of a reaction. The reaction in which we have zinc is reacting with a solution of copper sulfate, aqueous solution of copper sulfate, and resulting in the formation of zinc sulfate aqueous solution, and copper is given out. Well, in this reaction, if we analyze this, we have zinc metal which is introduced into a solution of copper sulfate solution, and this copper sulfate aqueous solution is blue in color. And when this zinc rod, solid metal zinc rod, is introduced into the aqueous solution of copper sulfate, blue aqueous solution of copper sulfate, after some time we see the color, the blue color of the solution fades away. And when it fades away, we get a colorless solution of zinc sulfate, which is colorless, and we have a reddish deposition of copper on the degraded metal zinc rod. Now, in this reaction, what happened actually? How the blue color of copper sulfate solution gets faded away. How it turns from blue color to colorless. And where from this reddish deposition on this zinc rod comes from. When we analyze this reaction and try to understand the chemistry behind, we see zinc is a metal. So is copper. But copper is present in the form of aqueous solution. And now what we do, we are introducing zinc rod in the solution of aqueous solution of copper sulfate. Now this zinc metal is more reactive than copper metal. This zinc metal is more reactive than copper metal, and this more reactive zinc displaces the less reactive copper metal from its salt solution and takes its place to form zinc sulfate. I will repeat, zinc is more reactive than copper metal, which is present in the solution form. Now, when zinc metal is introduced in the solution of copper sulfate, the more reactive zinc will displace the less reactive copper from its salt solution and will result in the formation of new solution, then solution of zinc sulfate. And the displaced copper, we see the red color deposition of the copper on the zinc rod, degraded zinc rod. So in this reaction, we observe that a more reactive metal displaces a less reactive metal from its salt solution and takes its place. Such reactions in which more reactive metal displaces less reactive metal from its salt solution and takes its place are referred as displacement reactions. Dear students, we are having so many examples in our book also to discuss and explain and understand this concept of displacement reaction. But you have to always keep into consideration that this displacement reaction will take place only then when we have a more reactive metal and more reactive metal is introduced in the solution of less reactive metal, then only this displacement will take place. It will not happen in the case if you have a less reactive metal and that is introduced in the solution of more reactive metal. It will not happen like this, that a less reactive metal will displace more reactive metal from its solution. No, it is always that a more reactive metal will displace the less reactive metal from its salt solution, and that's what is called displacement reaction. Now, after this displacement reaction, we will understand yet another type of chemical reactions. That's called double displacement reaction. The concept of this double displacement reaction is somewhat similar to that of displacement reaction. But here we have to understand this. In double displacement reaction, we have an aqueous solution of two salts. Let me take an example. Let me take an example of barium chloride. Aqueous solution of barium chloride I am taking in one test tube, and I am taking sodium sulfate in another test tube. Now I am having in two test tubes, I am having one is aqueous solution of barium chloride, and in another test tube I am having aqueous solution of sodium sulfate. When I look into these aqueous solutions, they are totally transparent, just water-like in their appearance. The aqueous solution of barium chloride and the aqueous solution of sodium sulfate. Now what I do, I mix these two aqueous solutions. Let me introduce the solution of aqueous solution of barium chloride salt into the aqueous solution of sodium sulfate. And when I mix them, what I see is the formation of white precipitate. Yes, the color of the reaction mixture changed from colorless to white. And this formation of white substance is due to the reaction between the two aqueous solutions, barium chloride and sodium sulfate. They react together and they result in the formation of an insoluble product, barium sulfate, which appears in the form of white colored precipitate, and our very common NaCl salt is also formed. Now we know NaCl is soluble in water, it forms the aqueous solution, but this barium chloride, which is an insoluble product formed, will result in the formation of precipitate. Yes, it results in the formation of white colored precipitate of barium chloride. Because in this reaction we see the sodium sulfate and barium chloride. If we see the ions in the barium chloride, that is Ba2 positive and Cl negative. In sodium sulfate, the ions were present as Na positive and SO42 negative. Now we see these ions were present in their respective solutions initially. And when we mix the two solutions, and now all these ions come in contact with each other, they simply, what is said, there takes place the exchange of ions. When I say exchange of ions, the ion barium goes with sulfate, and the ion sodium, it goes with chlorine. So there is a preferential affinity of these ions for each other. Na and Cl combine together, resulting in the formation of NaCl, aqueous solution, which is there in the solution. And this barium and sulfate, when they combine together, they result in the formation of barium sulfate, a white precipitate, white insoluble precipitate of barium chloride, which we can see very much in this test tube. So in this double displacement reactions, they are simply referred as those reactions in which exchange of ions takes place, and these double displacement reactions, they mostly result in the formation of precipitates. Hence, they're also called precipitation reactions. Dear students, it's all about the types of reactions. We'll be seeing you soon in my next video lesson. Till then, stay safe, stay secure, and goodbye.